In this video, I'm going to explain the concept on how we could easily expand a binomial, especially when the exponent is already high. So for example, if someone will ask you what is the expansion of x plus y to the 10, then one possible way could be you multiply x plus y 10 times. Okay, so x plus y and then x plus y. So 1, 2, 3, 4, 5, another x plus y, 6, then times x plus y, 7, x plus y, 8, and then x plus y, 9, and then x plus y, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as you can see, you can do multiplication to each pair and then multiply the results afterwards. But just by looking at um, the expression right now, it seems like this is going to be a long way to expand x plus y to the 10. And not only that, sometimes um, we just want to find a specific term from the expansion x plus y to the 10, and it's not really practical to do it this way. So there must be a way on how to expand it. Okay, before I reveal it to you how we could do this, let's investigate on some smaller exponents. Now let's see what will happen if I have x plus y to the 0. So since the exponent of 0, so x plus y to the 0 is just 1. Okay? And if x plus y is raised to 1, then it should be equal to itself. If I have x plus y raised to 2, we know this to be x squared plus 2xy plus y squared. And then if I have x plus y to the cube, you can still get this from x plus y times x plus y times x plus y, which is the same as, so this is x plus y squared, so this is the same as x plus y times the result of x plus y squared, which is x squared plus 2xy plus y squared. So as you can see, even as low as cube, it is taking us some time to expand the expression. Okay, but let's finish this. So this will become, so x plus y gets multiplied to x squared, so you have x squared times x plus y plus 2xy, and then times x plus y, and then finally y squared times x plus y. So this will become x cubed plus x squared y plus, you multiply this, 2x squared y plus, you multiply 2xy squared, and then y squared times x is xy squared, and then y squared times y is y cubed. And we try to look at some of the similar terms. So this is x squared y, so this can be combined into 3x squared y. At the same time, I have xy squared, all in all I have 3x y squared. Let's change that, 3x y squared, and then plus y cubed. So the expansion of x plus y cubed is equal to, so let's copy that, x cubed plus 3x squared y plus 3xy squared, and then plus y cubed. Okay, and if I continue like x plus y to the fourth, then that would mean x plus y times the whole thing here. Okay, but it will be very tedious, so we have to look for a way on how to make this simple. So here, now let's look at the coefficients of x and y obtained from here. So 1 is 1, so this is just 1. Okay, this is 1x plus 1y, so 1x plus 1y. And then this is 1x squared plus 2xy, and then plus 1y squared. And then this is 1x cubed plus 3x squared y plus 3xy squared, and then 1. Okay. So actually we're forming like a pattern here. One discovered this pattern and it is named after him. So we call this pattern of numbers actually the Pascal's triangle. Okay, so you can like search for that, Google that, and how Pascal was able to discover this pattern. Okay, but what is the pattern really? If I were to ask you, what do you notice about the numbers? Okay, give you some think time. You might say, oh, they're all 1 at the sides. Seems to have like increasing number 1, 2, 3. Okay, but actually the pattern comes from here. This number here is the sum of 1 and 1 above it. Okay, this number 3 is the sum of 1 and 2. This 3 is also the sum of 1 and 2. Okay, and all the numbers at the side are just 1. Okay, so that's mainly the pattern. Now, if I will expand x plus y to the fourth, we expect that the coefficient of x and y will be, from the pattern, we have 1, 4, 1 plus 3 is 4, 6, 4, and 1. Okay? Do that, expand x plus y to the 4, and you will get these numbers for sure. Okay? And I can continue like to the 5th, and to the 6th, and to the 7th, to the 9th. Okay, now going back to our goal, goal mainly is to find a way to easily expand x plus y to a big exponent. Okay, so from here, the Pascal's triangle will be providing us with the numbers that will be used for the expansion. Okay, let's work on the x plus y to the fourth. So suppose we want to extend our expansion and we want to expand x plus y to the fourth. Okay, so aside from the pattern in the numbers, I want you to take a look at what is happening with the x, okay, from the expansion of x plus y cubed. Okay, take a look at it. Okay, try to observe. Oops, there's no more x. Okay, at the same time, take a look at y. Oh, no y here. And then y squared, and y cubed. Okay, so try to observe. Okay, so I hope that we have the same observation, that the x is actually decreasing its exponent by 1. And the highest exponent is coming from the desired expansion, which is raised to 3. So we have x cubed, x squared, x, and no more x. Now the y, the second term in the binomial, takes the opposite pattern. So there's no y, there's y to the 1, y squared, and y cubed. That pattern actually holds to any x plus y raised to a given exponent. Okay, now combining these ideas to expand x plus y to the 4, remember we can use the numbers in the Pascal's triangle, okay, for the coefficient. So we know that this will be 1, 4, 6, 4, and 1. Okay, following the pattern for the x, So x will start with the 4, then cube, then square, and x, and then no more x. The y, so no y. No y actually means y to the 0. No x basically means x to the 0, which is consistent with the pattern and the exponents of x and y. Okay, so for the first term, there's no y, there is a y, there is a y squared, and then there's a y cubed, and then there's the y to the 4th. Okay, so that's basically completes the values for each term in the expansion of x plus y. So these are all positive, as you can see. So plus, plus, and then plus. Okay, so simplifying this, 1 times any value is x to the 4, and then 4x cubed y, and then 6x squared y squared, then 4x y cubed plus y to the 4th is the expanded form of x plus y to the 4th. Okay, so as you can see, we can expand a binomial to like some exponent, the desired exponent, by combining the concept of the Pascal's triangle and the pattern that we could see from the x and the y. Okay, now as an exercise, I'll be leaving one problem for you to work on, and hopefully you can do the expansion of x plus y to the 5 on your own. So tip, use the Pascal triangle, and then use the pattern for x and y. Okay, now for now, take note, this is the introduction for the binomial expansion. We will be working on, there's an even faster way of expanding binomial. Okay, but for now, uh, be familiar with the Pascal's triangles and the pattern of x and y to expand an x plus y, or later on this can change, but x plus y raised to a given exponent. Okay, that's it.